Thanks a lot. So our wonderful Lynx Service Platform features many different services that, well, actually 16, and we split them into different categories. And I will give a very short overview of those categories, and then we will go into details of each category, and we will have examples of some services presented by different partners. First, there are 7 services that produce enrichments to the incoming documents. Of those, 5 produce different annotations in text, and 2 convert the whole text of the document into something else, something like summarization or machine translation when you translate the whole document. Then we have 4 services that are dedicated to search and information retrieval, 2 services related to vocabulary data, and 3 basic platform services that enable the functioning of all those services together in workflows and in a secure way. We have this nice page where you can go and have a look at all the different services and additional informations such as small demonstrations, videos, or their open API description. Next slide, please. Yeah. And now we would like to start with annotation services. We have 5 of them. Those are temporal expressions, geographical named entity recognition, more general named entity recognition, relation extraction, and entity linking. Next slide, please. And here I would like to pass the word to Maria.
Okay, thank you, Artem. So I will present the first of the annotation services in Lynx, that is the temporal expression service. In this service, we annotate the following type of expressions: dates that are calendar expressions like April, full dates like the 23rd of May, or years 1998, but also relative expressions like yesterday, 2 days ago. We also annotate clock expressions we call times, like 2 o'clock, 5 p.m., any format you can imagine to give time. We also can find sets that are very, very important in the legal domain. These are expressions that repeat over time, like Thursday, twice a month, yearly. We also identify durations, also composed ones like 2 days, 2 days and a half, 3 years and 3 months, and so on. And we are also working on detecting intervals. That it's something that it's not covered by state-of-the-art temporal expression services. So we are able also to find intervals like from the 3rd of April to the 6th of May, from 1 to 2, and so on. Next slide, please. So once we detect these expressions, we do what we call normalization. This is give a standard value to each of these expressions. So for instance, in this sentence, in 1998, it increased exponentially, and that summer something happens. The first expression, it's straightforward, it's a year, so the standard value is 1998. But the second one, that summer, okay, from this excerpt, that summer, we can derive that it's the month, it's summer, of course, the season of summer. But from the text, from a previous expression, we can also derive it refers to a specific summer, namely the summer of 1998. So our task is also to anchor this expression to a calendar, so it can be used for further application. So the normalized value here would be summer of 1998, that we express 1998 SU because it's an ISO standard to represent dates. Next slide, please. So this is what the temporal expression service does, and we cover the following languages. For Spanish, English, and German, we have developed a dedicated approach to the legal domain, a rule-based approach that are able to cover also some legal expressions that are not covered by state-of-the-art taggers. For English, it has been developed by UPN, and for German, it has been developed by DFKI. And we are also able to identify expressions from Italian and Dutch text, but for these languages, we don't have a legal development. We use a state-of-the-art temporal tagger that it's an external tool. So if you want to know more about this service, please check the Lynx YouTube channel, that among other nice videos, you will be able to find a demo and more information about this service. Thank you for your attention.
Thanks a lot, Maria. And next, we would like to have a look at named entity recognition services presented by Julian from DFKI.
So thank you very much, Artem. Yeah, I will try to give a short or small overview about the name entity recognition services. These are two, the general domain one and the geolocation that will come after that one. And probably most of you will know, but always a small introduction is nice. What is the goal of the recognition of name entities, or what are name entities? So mainly when we talk about name entities, those are proper names about cities, persons, organizations, like Paris, Berlin, Barack Obama. These are common examples, and this is interesting to identify, because then with this starting point for the natural language processing tasks, we can go further and use this information to start more complex processes as event detection, relation extraction, and many others. In the Lynx project, for the general domain, we have focused on 4 different approaches or model families that are statistical language models. Those are the simplest ones. Then an improvement on that ones that are the BERT-based neural networks. These 2 model families are focused on generic Wikipedia training data, so generic and general domain, while the 3rd and the 4th, those are the conditional random fields and the bilateral long short-term memory neural networks. Those are specifically trained for the legal domain. That is the interesting and the focus of the Lynx project. In that case, due to the lack of specific training data for such a system, we focused on generating a German core decision corpus, manually annotated, that was composed of 67,000 sentences and 54,000 entities divided in 7 coarse-grained classes that are then subsequently split in 19 fine-grained classes. Please, next slide. Here we have a brief overview of the different classes, because that was a hard work to define which classes we can define, because this is completely domain specific, in this case for the legal domain, that is the focus. And the different fine-grained classes were manually defined and then checked by 2 other annotators in order to have a good coverage of the different entities that could appear in the legal domain. This corpus was used to train the 2 specific legal models for the German language. Next slide. Now, as a next step, we went to the development of a specific service for the identification of geolocation entities. Those are generally part also of the name entity recognition system, but in this project, we decided to split it in a different service because locations play an important role in legal domain. For example, if we think about the analysis of contracts, of rent contracts, it's quite important to define where the object is located. And this service focuses on that. And in that case, we have specialized the service in order to use also a dictionary-based approach and a rule-based approach that allows us to identify specific entities such as companies from a Spanish dictionary or specific addresses using regular expressions. Next slide. In order to train the language model, we also used a manually annotated corpus that can be partially seen in the slide, that it's composed of 17 fine-grained classes for locations that are not specific for the legal domain, but this is still something that we are improving and further developing. Next slide. Here we just included the regular expressions that we define for the addresses, just in case that somebody wants to replicate or use them in other approaches. But just to say that they are working quite okay, but there is still some space for improvement regarding regular expressions and legal domain and legal documents at least. And that's it from my side. Thank you very much.
Thank you very much, Julian. That's really cool that we are trying to recognize entities using different approaches. This makes the whole service more robust. Now I myself going to give a short overview of entity linking and our specific entity linking. You will see why the task is a little bit special in our case. First, we would start with a general understanding. So what we try to do with entity linking. On the right-hand side, you can see those pictures, and on the very right, you see the sentence. BMW has designed a car that is going to drive Jaguar X1 out of the market. So the task would be to connect all the entities that appear in the text to entries in a knowledge base, to concepts in a knowledge base. And this is the usual task statement when you expect that for Jaguar, you would be able to find all the relevant senses in the knowledge base. This is usual setting. This is used for large knowledge bases that cover almost anything when you work with something like DBpedia or WordNet. However, for the legal domain and for the legal knowledge graph, we are focusing on the legal terminology only. Therefore, we would not have such general purpose senses as animals or anything else. Therefore, we would not be able to see all the possible senses of the word. Therefore, we relax our assumption, and what we actually want to do, depicted at the right bottom part of the picture, is that we only have one entity representing Jaguar in the knowledge base, and we would like to disambiguate if the one that we find in the text is the correct one. So in this particular example, it is incorrect because we have animal Jaguar in the knowledge base, and we have Jaguar as a car in our text. So in frames of the Lynx project, we have developed a service that is able to tackle this task, and that is able for each mention to correctly disambiguate if that one is meant in the sense of our knowledge base or not.